Hello, I am Professor Shalini Sahay from EC Department, SIRT Bhopal. Today in this lecture, we will discuss about the magnitude response of high-pass filter as practical 2. First, the aim is to plot the magnitude response of high-pass filter. In this practical, we are discussing the passive high-pass filter. A high-pass filter is a circuit that can be designed to modify, reshape, or reject all unwanted low frequencies of an electrical signal and accept or pass only those signals which are wanted. Passive filters are made up of passive components such as resistors, capacitors, and inductors, and have no amplifying elements like transistor, op-amp, etc. So they have no signal gain, therefore their output level is always less than input. Now we'll discuss the RC high-pass filter. An input signal is applied to the series combination of non-polarized capacitor and resistor. It is a first order filter as there is only one reactive component in the circuit, and that is your capacitor. The filter output will be available across the resistor. The combination of this DO are exactly opposite of low pass filter. At low frequencies, the reactance of the capacitor will be very large and it will act like an open circuit and block the input signal below the cutoff frequency point. But when the cutoff frequency point reaches the reactance of the capacitor, it will start to reduce and allow the signal to pass directly. Now the cutoff frequency, the range of frequency for which a filter does not cause significant attenuation is called the passband, and the range of frequency for which the filter does not cause significant attenuation is called the stop band. And the cutoff frequency of an RC, a low pass filter, it's actually the frequency at which the amplitude input signal is reduced by 3 dB. In case of high pass filter, it is increased by the 3 dB. So now the output voltage calculation. In the RC circuit, there are two resistive things. One is resistance and other one is the capacitive reactance of the capacitor. So we need to measure the capacitive reactance of the capacitor first, as it will need it to calculating impedance of the circuitry. Impedance denote as Z. Here the Z is equal to under root of R square plus XC square. Now the gain will be R upon Z, and that is denoted by V out upon V in. Now we'll discuss the MATLAB code for it. We have taken the frequency omega on the x-axis starting from 0 ends to 500 with an interval of 0.01. G will define the gain, and gain is your j omega upon 1 plus j omega. As we want the magnitude gain for each frequency, therefore we have used this dot. The magnitude response always drawn on the semilog paper. So we have taken the semilog x command, which will plot on x-axis W, and the absolute value of gain will be plotted on y-axis. We have put the grid on. We have made the title as magnitude response of the high pass filter, X label as the frequency, and Y label as the gain. And when we run this program in the MATLAB, this response of the high pass filter comes like this. Now, I will also discuss this program by sharing the MATLAB. In this, I have written the MATLAB code for this program. W, G, we have defined the gain. Semilog, we have defined on the semilog axis W and absolute value. Grid on, we have put the title magnitude response of the high pass filter. We have X label and Y label. After writing this program in the editor window, we have run this program, and the plot will be like this. For the low frequency, the gain is small or 0, and as we increase the frequency, the gain will tends to 1.